Welcome to Lesson 5, Topic 4. In this video, we're going to continue our exploration of the for loop to repeat a process. But in these examples, we're going to see how we can use the loop variable to modify the process that's occurring inside the for loop. To do this, we're going to play around with the Neopixels. So let's get to it. Alright, so we have our base code here of a for loop that's going to run 3 times with the value of I changing, and let me do that as a comment just so we kind of keep this in the forefront, that the values of I will be 0, 1, and 2. And if you kind of imagine what that's going to do, it's actually going to change the Neopixels in position 0, 1, 2 because we're using the value of I as part of set pixel color. Now, if I wanted to shift this over to positions 1, 2, and 3, you may be tempted to do something like this. Simply shift the start and end point, which would work. And let me run that for you just to prove to you that if this was your initial thought as to how to move the Neopixels, that you were correct. This will shift the Neopixels to positions 1, 2, and 3. But let me offer you an alternate way of doing this. So let's keep the value of I with 0, 1, and 2. But now instead, let's add 2 to the value of I. Now this isn't modifying the value of I. This is simply adding 2 to I. There's a difference there. Okay? This is not this. This would modify the value of I by 2. This is simply using the value of I, adding 2 to it. Well, in this case, let's add 1. And then using that value. So you can see here, we got the same results. And if you kind of imagine or think it through, if I did I plus 1 here, that means that for every value of I, I'm simply going to add 1 to it. So 0 becomes 1, 1 becomes 2, 2 becomes 3. So if you think about it, we can actually extend this further. So if we were to do an I plus 2, so I is 0, so plus 2 would be 2, 3, and 4. And let's check that out. So you can see here, we've kind of moved the Neopixels further. Now, I'm not going to go through the whole, example of adding 3, adding 4, but hopefully you can understand that this offset is making the Neopixels move. So because I kind of use that word offset, let's write it in. Now, if I create this, that means that's a variable, which means we have to declare it up top. And let's set it equal to 0. Now, the interesting thing that's going to happen, I guess I could leave those in there, is that right now, if I left it at 0, it would be the same thing that we had originally. But what if I did this? Offset plus plus. So as the Arduino loop loops around, it's going to increase the offset. Now remember, this number that gets added to I shifts the Neopixels. So if you kind of envision it, the Neopixels should now move. Let's check that out. Alright, so a cool effect, but now you notice that the Neopixels go away. And we've tackled this problem before. And in the back of your mind, you're thinking, oh, maybe we could use an if statement. You could do that, or I would challenge you to go back and review in one of the earlier videos the modulus operator. The modulus operator is a great operator that will allow you to kind of bind a value within certain limits. Technically, the modulus operator is used to determine the remainder of an associative division. But again, I'm going to leave you to look at the past video. I believe it was in lesson 2 series to review how the modules operators works. So I want to create another variable here. Let's call it position. And let's set the position equal to I plus the offset. And now if I did that, I could simply replace this with position. And if you recall, I mean, this is one of the good uses of variables to kind of simplify a process where when we get down to the actual place where it's used, it's just about, okay, here's a position. The fact that we're modifying how the position is calculated, that's another process. So what I wanted to do here was, I'm going to take that value of the I plus the offset and do a modules of 10, which would bind our values between 0 and 9. Again, anything that's divided by 10, the only possible remainders will be 0 to 9. Again, I'll leave that as a review for you on your own. So let's check this out, and to have some fun, let's speed this up a little bit. Let's upload that. And now you can see we're having the Neopixels go around. But not to lose sight of what the goal of this video is. We used the for loop to repeat a process. That process was simply to color 3 Neopixels. The fact that we used the loop variable as part of our process, that's a different story, and that's a little bit of the goal for this video, is to show you that you can do a lot with this loop variable. And I have a couple of examples already typed up to kind of demonstrate that. So let's look at some of those examples. Hopefully you're excited about this part right here, but I think you might enjoy some of these other examples I have canned up for you. So let's look at this one. All right, so I took this example, and I'm going to shorten it up a little bit. I'm going to start with just these two, in that it's the same basic code. This is the exact same code from the previous program, except that now I added a +3. So let's think about that. We're doing this all together. So this would be I plus the offset. So the first time we go through this, it would be I 0, 1, and 2. For this one, again, I'm thinking the first time we run this program when offset is still 0. So if this is 0, this essentially just becomes I plus 3. And what is going to be I plus 3? So this would be 3, 4, and 5. So if you kind of notice, what we're doing here is we're coloring 3 sets of consecutive Neopixels, where the first 3 will be a certain color, red, the next 3 will be green. And then we're using that same technique of the offset and the modulus to kind of move this around. So let's bring up the camera. So essentially it's the same thing as the first example, except we have another set of colors. Again, some students might think, well, we could have done that with another for loop. We could have. But again, why use another for loop? We already have a for loop that's repeating a process 3 times. The fact that that process now colors 2 Neopixels is a different story. And I want you to think of it like that. The process that goes inside the for loop could be as complex as you want it to be. And that's what the initial example was, which is now we're going to do 3 sets of colors. And just for the sake of completeness, I'm going to do the same thing here, which is an I plus 6 would then give us position 6, 7, and 8. So we have 3 sets of consecutive Neopixels, each with a different color of red, green, and blue. Let's run this. And trust me, you can have so much fun with this, just modifying numbers, thinking of different processes that you can do with this. Now, if you kind of like this, colorfulness and movement of the Neopixels, I think you'll enjoy the next example. So let's get to that one. Actually, you know what? Let me do this one first. I got ahead of myself on which example I wanted to show you. All right, so we're doing something slightly different on this one, and I'm going to do the same thing we did with the previous video, which is let's look at what the values of I are. Again, that's important. The loop variable is what's dictating which positions are being used for the set pixel color. So the first time we run through this, we already know it's going to be 0, 1, 2 because the value of offset starts off at 0. But now let's see what's happening down here. And I don't even know what to call this. let's call this position. So we got the same offset here. So the I plus the offset. So if this is 0, this is just I. So essentially this boils down to 10 minus I. So when I is 0, 10 minus 0 is 10. 10 minus 1 is 9, and 10 minus 2 is 8. So hopefully you can kind of envision this is coloring the Neopixel. And I guess I really should have done this minus 9. I'll make that switch on the fly. Okay, so this will color the first 3 Neopixels. This will color the last 3 Neopixels. Now, as the value of offset increases, and let me do that. So this would be an I plus 1. When offsets, it's equal to 1. So that means this would be 1, 2, and 3. Now, when we do that, the value of position, again, using this other one, I'll just leave it like that. I don't want to put plus 1 because then you're going to think of adding 1. Let's just say the new iteration of this plus the offset. So now we're using these values. So a 9 minus a 1 becomes an 8. An 8 minus a 9 minus a 2 becomes the 7, and then the 9 minus the 3 becomes 6. So you can see what's happening here. These Neopixels are going to move counterclockwise because they're increasing. These Neopixels, because of this calculation, will move clockwise. It might be easier to kind of accept it if you see the result of it. And then I would challenge you, if you want to do a couple of serial print lines of these values, that is definitely the best way to kind of learn. Now, we've done this before in previous videos, simply by using 2 different sets of variables. What I want to show you here is the fact that you can use a for loop and simply be creative with the way you use those variables in the for loop, that loop variable, and maybe some other external variables to get the same effect. Okay? So what I want to do now is I want to get to that last example, which is extremely colorful. And that's this one. All right, so first thing you'll notice is it's a lot shorter. So this is not doing anything special in terms of that position. This is the same thing we saw in the first example. What is different here is that, again, we're talking about using that loop variable as part of the process and how it can help us to modify how things look. So I'm taking advantage of the Circuit Playground color wheel, which ranges in values from 0 to 255. But it has its own specific color wheel where, the value of 0 might be a red, the value of 255 would be a blue. I honestly don't remember off the top of my head. Maybe it's violet, thinking kind of like the rainbow colors. But what I'm going to do here is that for each Neopixel, I'm going to take that value of I and multiply it by 2. So what kind of values are we getting here? This would, and let me write it down as I times 20. So the first Neopixel, the one that gets colored in the first position, would have a value of 0. The next one 20, the next one 40, 60, 80, and so on, all the way up until, I believe we'll get up to 180 because the last value of I would be 9. All right, so let's run this and see what we get. All right, so a couple of things are happening here. First, I want you to definitely enjoy the rainbow of colors. But But then I want you to take a little closer look and see what's happening to that rainbow of colors. Notice how it's moving around. That's because we combined that first solution of the POS using that offset with the modulus to bind it within the appropriate values for position for set pixel color. But then we also use the circuit playground color wheel, and we also use that loop variable to modify which colors we get. Again, you can have a lot more fun with this too by simply changing the different types of numbers that we use as part of the color wheel. Alright, so let's go back to our presentation and review what we've done in this video. So we saw how we can use a for loop to repeat a process and keep that process constant in terms of the number of iterations that it runs. Doesn't mean that the process inside has to be stale. Again, by using that loop variable, we could create some interesting effects in terms of, in this case we were playing with the Neopixels, in terms of positions that we used, the colors that we used, something to think about. I didn't demonstrate it in the video, but you can use random numbers too as part of the process inside the for loop. So hopefully you're excited, and I look forward to seeing what colorful things you can do with your Circuit Playground Express. Enjoy.